Today, we're diving into a cosmic detective story. We're on the hunt for clues that could point to a fifth fundamental force of nature. A discovery that would completely rewrite our understanding of, well, everything. So, let's get right into it. Okay, first things first, we have to wrap our heads around the sheer scale of this mystery. Because everything we see, every star, every galaxy, you, me, it's all just the tiniest tip of a colossal cosmic iceberg. And this really puts it all into perspective, doesn't it? Get this, over 95% of the entire universe is made of stuff we call dark matter and dark energy. It's this invisible realm that doesn't interact with light at all. The only reason we even know it's there is because we can feel its gravity. But what it actually is, a total and complete mystery. Which, of course, leads to a massive question. If the four forces we know and love, gravity, electromagnetism, the strong and weak nuclear forces, if they only run about 5% of reality, then what in the world is governing the other 95%? It's like we're missing the fundamental rulebook for almost the entire universe. Now, in any good investigation, the first thing you do is look for clues, for inconsistencies. And in cosmology, we are finding some major ones. These are the cracks in our standard model of the universe that hint at something much, much deeper going on. So while there are a few big puzzles keeping physicists up at night, there are two in particular that are really driving this search. First, the simple fact that dark matter exists at all. And second, this really glaring contradiction in how we measure the universe's expansion. It's a problem known as the Hubble Tension. And this is where things get really, really sticky. See, when we look at the universe in its infancy, right after the Big Bang, and we use our best physics to predict how fast it should be expanding today, we get one number. But then, when we actually point our telescopes at galaxies nearby and measure the expansion rate directly, we get a completely different number. You can see the conflict right here on the screen. The data from the ancient light of the Big Bang tells us the universe should be expanding at about 67 kilometers per second for every megaparsec, which is just a ridiculously huge unit of distance. But our direct measurements of the universe today clock it at about 73. That's a difference of about 8%. The numbers just don't lie, and right now, they do not match. So, what on earth could be causing this? What could explain this cosmic mismatch? Well, this is where our prime suspects finally enter the picture. And it leads us to this incredible idea of entirely new forces of nature. One of the coolest ideas out there is that this dark sector is kind of like a parallel world, hiding in plain sight. It might have its own family of particles and even its own forces, carried by things physicists are calling dark photons. Think of it like a kind of light that only dark matter can see. And this is really the umbrella term for the whole investigation, a speculative, undiscovered fifth force. A new force could be the missing link, mediating interactions between dark matter and dark energy, or maybe even subtly tugging on regular matter in ways we just haven't been able to detect yet. I love this theory because it gives us a brilliant reason for why we might have missed it for so long. These are called chameleon forces, and they would change their strength depending on their surroundings. Here on Earth, or in our solar system where matter is dense, they'd be incredibly weak, practically invisible. But out in the vast, empty voids between galaxies, they could become powerful. Okay, so let's say these forces are real. What do they actually do? I mean, how would they change the universe that we see? This quote from a recent paper just sums it up so beautifully. A fifth force wouldn't just be some little footnote in a textbook. No. It would be an active choreographer scripting this grand, invisible ballet and shaping the very structure of the cosmos. And this new force could have some really dramatic and totally opposite effects. For instance, if the force is attractive, it could pull dark matter together into these ultra-dense clumps, maybe even seeding the supermassive black holes we see at the center of galaxies. But if it's a repulsive force, it would do the exact opposite. It would puff up dark matter halos, which could actually help solve some other puzzles we have about small galaxies. And if you want to get really wild, in some extreme cases, these forces could be strong enough to literally shatter halos of dark matter into these bizarre oscillating fragments called oscillons, and that shattering could release a storm of gravitational waves that we might one day be able to detect. How cool is that? Now, this isn't just theory or science fiction. This is real. Physicists are actively on the hunt for these new forces on a bunch of different fronts. So let's take a look at how the investigation is actually going down. The search is basically happening in three different arenas. You've got particle physicists in labs smashing things together and looking for weird new particles. You have astronomers using massive telescopes to map the entire cosmos, looking for the large-scale effects. And then you have cosmologists using supercomputers to dig through all the data we already have, hunting for the subtle fingerprints of a new force. And things are really starting to heat up. It started with little hints, like a mysterious anomaly called X17 that kept popping up in a lab in Hungary. And now we're building things like the Vera Rubin Observatory, which is going to create the most detailed map of the dark universe we've ever had. We are absolutely entering a new era of discovery. But you know what? Maybe the most exciting clue we have so far comes from combining all of our best measurements of the universe. I'm talking everything. Data from the cosmic microwave background, from distant supernovae, and from the web-like structure of galaxies. And here it is. This is the result that has physicists buzzing. A recent analysis found that when you combine all that data, a model of the universe that includes a chameleon-style fifth force just fits better than our standard model. Scientists use this score called chi-squared to measure the goodness of fit, and a littler number is better. The fifth force model improved that score by -6.41.
Now I know a number like -6.41 might not sound like a huge deal, but in precision cosmology, it's significant. It is one of the strongest statistical hints we have ever seen for a brand new interaction between dark matter and dark energy, an interaction that our standard model says flat out shouldn't exist.
So, we've reviewed the evidence. We've looked at the suspects. Where does that leave us? What's the verdict in this cosmic case? Well, the case is definitely not closed, not by a long shot. The clues are compelling, they're tantalizing, and the statistical evidence is growing, but it's not definitive proof. You've heard it before, extraordinary claims require extraordinary evidence, and right now scientists all over the world are in a race to either confirm or debunk these findings. Look, we know for a fact that our story of the cosmos has a huge chapter missing. The search for a fifth force is really the search for that missing chapter. And whatever we find when we finally turn that page, you can bet it's going to fundamentally change our place in the universe.